Hello everyone, Brent Blankenship here, Applications Engineer with Advanced Industrial Products, here today to do a application demonstration for the Omron TM Collaborative Robot or cobot. Particularly today we're going to be using or looking at the Omron TM's landmark feature, which uses this little TM landmark, which is I think it's 40 by 40 placard. It's a known entity in the TM's world, so using the built-in vision system, it comes standard with the robot or the cobot. You use this as a reference point for programming. So if you wanted to roll the TM on a cart up to a machining center and you just wanted to kind of hold it in place, clamp it in place, use some leveling screws or something to lift the cart off the floor, you could use this, and then you could use the vision system on the robot to pick this up, see where it's at in its field of view and in its world, and you're basically going to create a new coordinate system off of this. So it gives you a lot of flexibility to be able to roll the TM up to somewhere and just make sure that this is in the field of view, and then you can use this as the starting point, so you don't have to get your robot perfectly in the exact same spot every time. It's a very flexible feature. It's very easy to teach. Today we're going to be using a palette that I use for demonstrations. It's going to have a TM landmark right in the middle of it. Kind of see there's 8 holes here. It's a 9-hole palette pattern, but I've removed the middle one for the TM landmark. These are 17 millimeter outside or inside diameter holes, and we're going to be using a black 16 millimeter inside diameter or outside diameter pin. So we'll be using a palletizing. We're using the vision to pick the parts off of the table. Pretty good application. I use this to show people just how accurate this is on both the X, Y, and Z and rotation of X, Y, and Z as well. So let's hop right to it. Alright, here we are with the actual application I was just discussing, using some 16 millimeter black pins as basically just parts on a white background, this is actually the back of a dice board that we use to set the TM up for other features. We're going to be picking and placing these pins, which are 16 millimeters in diameter, into these 17 millimeter holes that are on this, we'll just call it a pallet. And every time we're going to take a picture of the whole field of view, and then we're going to pick and place the pins. It will take one picture, then it will pick and place all the pins of which it's seen in that single vision job without anything next to them, and then it will pick them and place them. Every time it comes over here and places here, it's going to take a very high TM shot to locate the TM in the field of view, then it's going to get a little closer to kind of get your best accuracy. It's just a best practice to do that with the landmark feature. Kind of get close with one and then really get accurate with the other one. So additionally, the robot is running, it's currently in a vision job right now called a Vision IO job, so it's waiting for something to come into a certain part of its field of view to start the program. So I'm just going to put my pointer in that field of view, and you'll see it's going to take a picture, and then it's going to locate and pick and place these pins into the pallet. Every time it's going to reference that TM landmark and then drop them off. So if I reposition the pallet, or the world changes and reference that robot, it makes up for that using the TM landmark. You'll notice it went ahead and rotated itself probably 30 degrees to fix that issue. Once again, we'll do it just the other direction to kind of showcase that feature working in more than one direction, so it's not a gimmicky sort of look. I'm not trying to pull the wool over anybody's eyes or anything like that. And you'll notice it just keeps picking and placing. So as soon as it gets finished here, I'll reposition them into the field of view, the remaining pins, and then we'll kind of do some rotation of X, Y, and Z, you know, how much of an angle can it deal with and things of that nature. So now you can see that I've kicked the plate up there. It's approximately a 40 millimeter piece of extrusion, so it's like 1.5 inches roughly. I'll go ahead and restart it using that Vision IO. See that picture get taken. It's going to pick and place these 3 in corresponding of best correlation to lowest. Nothing really important about that, I just want to point that out. And you'll notice it'll go ahead and make up for it both directions and angle. We could do this all day, but just to try to get the point across of how this TM landmark and using it with the TM Cobot can really be a versatile tool to use in your facility. You know, you can put that TM landmark on a machine or a machining center or a cell, and then you can push your TM right up to it. Just secure it to the floor in some way, either jack screws or some sort of bolted in, but the robot doesn't have to be exactly placed. And so you'll just start your robot up, and then it'll reposition itself off this TM landmark and then run its programs from that point. Very versatile tool to be used throughout your facility. If anyone has any questions or comments, please feel free to reach out in the YouTube comments, email us, call us. We'd love to talk to you about the Omron TM, and we'd also really enjoy the opportunity to come to your facility and check out your application in person, do an in-person demonstration. And I think that's about it, guys. This is Brent Blankenship with Advanced Industrial Products. I appreciate your time.